Namaste to all my dear students. So I am giving you very interesting lecture about the oxidation number, or we can say oxidation state. That is very important to know which one is oxidizing agent, which one is reducing agent. Yes, so many things we learn when we know about the oxidation. So at first we have to know what is oxidation. Oxidation number, or we can say oxidation state. So when you talk about the what is oxidation number or oxidation state, so simply we can say it is a charge assigned बने को having or we can say containing. So it is a charge assigned to an atom in a molecule, or we can say radicals. Yes. So when we talk about, suppose we take very simple example like nitric acid. So when you find the oxidation number of nitrogens, if all the three are unknown, so we cannot find the oxidation number of this nitrogens. For this, what we have to know? Some important rules. So for this, for finding any oxidation number, we need some rules. So 5 rules for finding oxidation. ON means oxidation number of an atom in a molecule. So first rule is generally. We talk about the generally. ON means oxidation number of free atom, better to say free atom and diatomic molecule have 0 oxidation number. So when you talk very simple example, for example is like this. When you talk about the zinc plus dilute HCl, so what you get? Zinc chloride plus hydrogen. So what you see over here? Zinc is free atom. It does not combine with another atom. So its oxidation number is also always 0. Its oxidation number is always 0. Any free atom has oxidation number is 0. When you talk about the diatomic, H2 is diatomic molecule, so its oxidation number is 0. Like other example, like maybe nitrogen, maybe oxygen, maybe fluorine, maybe chlorine. In all cases, what you see? Oxidation number of diatomic molecule is always 0. So first rule, according to first rule, so what you see? Generally, oxidation number of free atom and diatomic molecule have 0 oxidation number. Yes, first rule. Second rule, so you have to know all these rules. So second rule is generally oxidation number of oxygen atom in combined state is -2, but the exception of this one, exception are peroxide. For example, hydrogen peroxide, barium peroxide, sodium peroxide, potassium peroxide. In this case, what we have? Oxygen has -1. Yes, in this case, one oxygen atom has what to see? -1. Always keep in mind. Generally, in combined state is -2, but in what we see talk about the peroxide case. So what we see? -1. Second rule. Third rule is generally oxidation number of hydrogen atom in, I will give you so many examples. Combined state is +1. Exception hydride. Hydride H having negative charge. In this case, what we have? -1. You know, sodium hydride, when ionized, reversible sign. So what we get? So in this case, hydride case is -1. So generally +1, but in hydride case, what we see? -1. That is about the third rule. Fourth rule is like this. Oxidation number of ions or radicals are same as its charge. Charge. So when we talk about the example we take, so what you see in this case? So ions and radicals have same oxidation number as its charge. Suppose when you talk about, for example, when you talk about the sodium, it has +1. So what we have? Oxidation number is +1. Calcium, it has 2 positive charge. So what is +2? Aluminum has 3 positive charge, +3. Silicon +4. Its oxidation number is +4. So these are the cations. Yes, these all are known as cations. Yes. Next, when we talk about the, so chloride has 1 negative charge, so it has -1. Sulfate 2 minus, so -2. Phosphate, so what do you see? That is the phosphate. So what do you see? Oxidation number of ions, radicals are same as its charge. So chloride has 1 negative, so -1. Sulfate has 2, so what do we have? -2. Phosphate has -3, so what do we have? -3, like this. Yes, that is the fourth rule. Now the fifth rule and last rule is like this. Fifth rule, the algebraic sum of oxidation, algebraic sum of oxidation number of all atoms in a compound is 0. Exception radicals, ions, so always keep in mind. So the algebraic sum of the oxidation number of all atoms in a compound is 0. So now see the super example over here. So example are like this. Example. First one is oxidation number of nitrogen in nitric acid. So you have to find the oxidation number of nitrogen over here. You know, generally the oxidation of hydrogen is +1 in combined state. Here suppose X. Let one oxygen has -2 generally. So in 3 oxygens what we have? -6 is equal to 0. In compound always what we get? Algebraic sum of the oxidation number of all atoms in a compound is 0. So what we have? X is -6 plus what we get? +5. You know, simple expression over here. Second, oxidation number of sulfur in sulfuric acid. How many hydrogen? 2 hydrogen. So what you get? +2. Sulfur, let X. How many oxygen? 4 oxygen. So what you see? -8 is equal to 0. So what the value of X is equal to +6. Yes. Another example is third. When we talk about the what you see phosphorus in S3PO4, that is the phosphoric acid. So how much? 3 hydrogen over here +3. P suppose X. How many oxygen? 4. -8 is equal to 0. X is equal to +5. Yes. So also, as we also told you, what we see in compound, what we see? 0. So +3, what we see? +5 -8. So what do you see? +5 and +3 is 8, -8. How do we get? 0. So when we talk about the algebraic sum of the oxidation number of all atoms in a compound is always 0. So what do you see? +5, +3, +8, -8. How much? 0. Like this, in what do you say? Mn, manganese in KMnO4, that is potassium permanganate. So how many? K has 1 positive charge. Mn suppose X. How many oxygen? 4. So what do you see? -8 is equal to 0. So what the value of X? +7. So what the man is? +7. Like this. So what you see? Next one is what you see? Chromium in K2Cr2O7, that is potassium dichromate. So how much? 2 potassium. So what you see? +2 plus X, 2X, 2 chromium atoms, chromium. So what to get? 2X plus -14 is equal to 0. 2X is equal to what you see? 12. So therefore X is equal to 12 by 2. So what do you get? +6. Yes, you have. So in chromium case, one chromium atom has +6. In charge case, suppose sulfur in sulfate. So sulfur, you have to find the oxidation number of sulfur over here. So what do you see? Sulfur. What do you see? X. How many oxygen? 4. So what do you see? -8 is equal to -2. What the value of X? +6. Yes, -8 goes over. So what's +8 plus -2? What do you get? +6. Next one is carbon in oxalate. Oxalate, and that is known as oxalatine. Yes. So what do you see? So what do you get? 2X plus how many oxygen? 4 oxygen. So -8. So what is equal to minus 2? So what you get? 2x is equal to minus 8. So what you see? Plus 6. So therefore x is equal to what you see? Plus 3. So what you get? Carbon has plus 3. Like this, when you talk about what you see, nitrogen, generally asked in the examination, nitrogen in ammonium nitrate. Yes, so in this case we have to ionize this one at first. So what we have? NH4 nitrate. So ammonium has how much? What you see? X plus 4 is equal to plus 1. So X is equal to what you see? Minus 3. In this case, nitrate, X plus minus 6 is equal to minus 1. So X is equal to what you see? Plus 5. Yes, two values over here. In this case, nitrogen has minus 3. In this case, nitrogen has how much? Plus 5. So generally asking examination. Next one is what you see? Bleaching powder. Chlorine in CaOCl, that is the bleaching powder. So when ionizes, what you get? 2Ca plus OCl minus plus Cl minus. OCl minus means hypochlorite. Yes, what do we, how much in this case? What do you see? When we talk about the X plus minus 2 is equal to minus 1. So what do we have? X equal to what do you see? Plus 2, what do we get? Plus 1. In this case, plus 1. In this case, minus 1. Because one negative charge over here. You know, according to fourth rule. Next one is what we say, sodium thiosulfur in Na2H2O3. That is sodium thiosulfate. So what you get? 2Na. So at first ionize, better Na plus, that is thiosulfate. Yes, Na has already positive charge. Thiosulfate, what you see? 2X plus 3 oxygens, what we have? 6 is equal to minus 2. So what do we get? 2X, what is it? Plus 6. When go in right side, so what we see? 2X is equal to plus 4. X is equal to plus 4 by 2. How much? 2. Sodium has 1 positive charge, you know. Next one is what is it? Iron in K4FeCN6. K4, that is known as potassium ferrocyanide. Potassium ferrocyanide. So what you get? So what you see? K4, how many potassium? 4. So what is give? Plus 4. Iron, we have to find out. X, how many Cn? Minus 6. Yes, is equal to 0. So what you get? X equal to minus 6, 4. What you get? Plus 2. So in this case, iron has plus 2. If we suppose iron in K3FeCN6, so what you get? That is potassium ferricyanide. So what we have? 3 plus 3 plus x plus how many? Minus 6 is equal to 0. So x is equal to what you see? Plus 3. So in this case, what you get? Plus 3. Yes. Next one is Carrot's acid. So what's its formula is S2S5. Yes. So you have to find the oxidation number of the sulfur over here. So what you get? Always sulfur yes plus 1 minus 2 that is the peroxide linkage plus 1 minus 1 minus 1 minus 2. So what you get? Suppose X sulfur X plus 2 plus minus 2 to 4 to 6 to 8. What you see? Minus 8 is equal to 0. So what do you get over here? The value of X is what we had? Minus 8. So what we get? Plus 6. Always keep in mind, sulfur has maximum oxidation number is 6, not more than 6. Nitrogen has maximum number is plus 5. What do you say? Chlorine has maximum 7, not more than. Next one is what do you say? CrO5. Chromium we have to find out. So butterfly structure of this one. Chromium 0, peroxide linkage, peroxide minus 1, minus 1, minus 1, minus 1. In this case, minus 2. So how much? So the what to say? Oxidation number of chromium is plus 6. Minus 1, minus 1, minus 2. So how much? Plus 6. Yes. So what to say? X is equal to minus 1 minus 1 plus minus 2. Yes. Minus 1 minus 1 minus 2. What to get? 4 minus over here. Minus 1 minus 1 minus 2. So what we have? 0. S is equal to what you see? Plus 6. Chromium has plus 6. That is known as butterfly structure. Butterfly structure. Next one is next one 11, 12. Fe3O4. So that is the mixed oxide. That is mixed oxide. So at first that is composed of FeO plus ferric oxide. In this case plus 2. In this case plus 2. In this case plus 3. Oxidation number. Likewise, when talk about the Pb3O4, that is triplumbic oxide. Triplumbic oxide. So that is also what you see? Mixed oxide. Mixed oxide. So that is composed of what you see? Two simple oxide like PbO, plumbous oxide plus that is plumbic oxide, 2 PbO. So what you see? Plus 2. In this case what you see? Plus 4 oxidation number. Yes. So homework. So find oxidation number of following ions. You can find out the compounds easily. So what you see: nitrate, phosphate, iodate, carbonate, phosphate, nitrate, nitrite, that is nitrite, that is what you see, thiosulfate, sulfur we have to find, thiosulfate. Yes, I think you can find out any ions, any what you see atom of the compound, because I have given you so many examples over there. So thank you for watching this interesting video, and I think you have already subscribed it, and also convey your classmates, fellow ones, friends for learning. So thank you all.